As previously noted, when composing photons, W and Z bosons, the relation of the weak isospin and the intrinsic spin may have to be reversed. That is, a change in one expression's weak isospin could be equivalent to a change in another expression's intrinsic spin. For example, on this W boson, we have the -1 for its intrinsic spin, which is the correct quantum. But its weak isospin should be +1, and it is +1/2. So we can change the weak isospin on this outer Rishon expression so that now we have a weak charge of 1. But we would then also have to have a corresponding anti-outer Rishon change its weak isospin, and that will give us the correct value for a W boson and for a Higgs boson, which now has a weak charge of -1. And we can look at the spins again and see that the spin is -1 here and the spin here is 0, which are the appropriate quanta noun of spin and intrinsic spin and weak isospin for the W plus boson and the Higgs boson. Now, if we look here, we see we have a W boson which has a isospin of 0, and we have a possible photon that also has an isospin of 0. And if we look at the weak charges on these, we'll see that they are correct, where we have a weak charge of 1 and a weak charge of 0 on the photon. So we need to change the spin quanta here on this outer relating Rishon, and then it will now have the correct spin, and then we have to do so also on the corresponding anti-outer Rishon, and we will give it a photon a spin of 1. And so now these two bosons have the correct quanta. As pointed out, the photon is now a intrinsic spin of 1, and the W plus boson has an intrinsic spin of -1, and the weak isospin on the boson plus is 1, and the weak isospin on the photon is 0. So in this way, by switching or matching the weak charge an intrinsic isospin on these possible T expressions, we can make necessary corrections when composing the emitted photons W and Z bosons in this composite model.